So today we're going to combine two things that you already know quite a bit about. First of all, transformations, translations, reflections, stretching of graphs, and our basic exponential and log functions, which you see summarized below. Just as a brief summary, remember that an exponential function is of the form y equals a to the x, where our base is positive, and our graph is a growth or decay shape as shown above. Has a horizontal asymptote on the x-axis. Our log function is the inverse of our exponential. So if we switch x and y, we get this, and then if we write this in log form, we get this. So the log graph is the inverse of the exponential, meaning that if you take your exponential graph, either growth or decay, and reflect it across y equals x, you will get the graphs over here. And you'll notice that you have a vertical asymptote on the log graph. So what we want to do now is take our understanding of all of this and apply transformations to these functions. So remember that when we do transformations, we think of our function of the form a f of b x minus c plus d. And each of the constants a, b, c, and d transform the graphs in different ways. So let's attack this particular question. First thing I'm going to do is I'm just going to make sure that I've got everything separated out, my A, B, C's, and D's separated out so I can see what's affecting what. And the first thing that I often need to deal with is x. I've got a negative there, I've got a plus 1 there, and I really need to factor out the coefficient of x to separate the different things that are going on. So we have 3 times 2 to the negative bracket x minus 1 minus 5. Our base function, in terms of the graphs we just talked about, is an exponential function of 2 to the x, which we know is a growth graph. I'm just doing some table of values in my head for that. It's got a horizontal asymptote. It looks something like that. Just dot in the asymptote. Alright, and as with all transformations, we're going to add one transformation, one thing at a time, building up to our final result, which of course is this. So let's take the negative. So we're now going to graph y equals 2 to the negative x, and we know that when x is replaced by negative x, that's a reflection in the y-axis. So all of my core points are going to reflect across the y-axis. And so my graph is like this now. Moving along to the next step, I'm going to deal with the 3. Remember, we deal with the multiplying numbers to the x and the y first. 3 times 2 to the negative x. And the 3 out in front can be thought of as a vertical stretch by a factor of 3. Remember, some people like to think of the 3 as being over with the y, which it really is. And so y divided by 3 reminds me that I need to make my new y values 3 times the size to compensate for that dividing by 3. So however you want to look at that, on my red graph, all my y values have to multiply by 3. So I have a y value of 4 here, multiplied by 3 is going to go way up. 2 multiplied by 3 is going to be 6. 1 multiplied by 3 is going to be 3. And so my graph roughly is coming down here. And the final thing I deal with are numbers added or subtracted to the x and the y. Remember, the minus 5 is really y plus 5. If you bring it over, it's really with the y. So when I add my final transformation, replacing x with x minus 1 and y with y plus 5, or having just a minus 5 on the other side, however you want to think of that, that's a translation 1 unit right and 5 units down. Now, part of what we have to translate is the asymptote, and since the asymptote is a horizontal asymptote, it'll be affected only by the translation down. So my asymptote is going to come down 5 units. It's going to be there. And then I'm going to take my green graph, take my core points, and translate them 1 right and 5 down. Okay, so this point right here that I've x'd 1 over 5 down is landing there. This point in green on the y-axis, 1 over 5 down, is landing here. Let's just take this point here, 1 over 5 down. And since I know the graph is approaching this asymptote, it's going to look something like that. Alright, so to answer the questions above, the domain, remember our block graph is our final graph, our domain is all reals, as is always the case with an exponential function. Our range are the values of y above the asymptote, which is greater than -5. And the horizontal asymptote equation is y equals -5. So next, let's practice transforming a logarithmic function. So once again, we need to separate in our x what's happening. So our equation could be rewritten as y equals -3 log base 2 of 2 times x plus 3 minus 1. So our base function is a log base 2 graph, log base 2 of x, which we know is the same as 2 to the y equals x. So let's just get a couple of points for accuracy. When y is 0, x is 1. When y is 1, x is 2, 2 and 4. And we'll do a negative exponent as well. There we go. So we have 4 points of accuracy. We know there's a vertical asymptote on a log function. The base is more than 1, so we know it's the graph that swings up like this. But let's make this more accurate using my points. I know the function looks something like that. So let's start working through our transformation, starting with the multiplying numbers to x and y. I'm going to start with -3 this time. So y equals -3 times log base 2 of x, or if you prefer, y over -3 equals log base 2 of x. If it's with the y, the effect is the opposite of what you expect. So y is not being divided by -3, it's being multiplied by -3. If you just keep it in this position, it's being multiplied by -3, which does two things. The negative reflects the graph across the x-axis, and the 3 is a vertical stretch by a factor of 3. So all of my y values have to get multiplied by -3, which will reflect the graph across the x-axis. So y value of 0 is still a y value of 0. A y value of 1 is now a y value of -3 when it's multiplied by -3. A y value of 2 when multiplied by -3 is now -6. So my graph now looks like so. The next thing I'm going to deal with is the multiplying onto the x piece. So I'm now looking at y equals -3 log base 2 of 2x. And we know that replacing x with 2x is a horizontal stretch of the graph by a factor of 1/2. So all of my x values have to get multiplied by 1/2. So this point right here, half of its x value would be 1/2. If x equals 2, then half of its x value is 1. And if x equals 4, half of its x value is 2. So the graph is going to push inwards towards the y-axis. And finally, I'm ready to deal with the numbers that are added or subtracted onto the x. And I see that x is replaced by x plus 3. And the -1, which can really be thought of as y plus 1, those are translations. So the graph is going to be translated 3 left and 1 down. And because we have a vertical asymptote, the movement of that will be affected by the horizontal shift. So our vertical asymptote will be shifted 3 to the left. And so let me dot that in. Currently it's at x equals 0. Now it will be at x equals negative 3. Now the easiest way for me to do a translation on this symposium is to take my graph, make a copy of it, slide it 3 to the right, and 1 down. So it's approximately there. But let me do this by hand to make it a little bit more accurate. It's just very hard to graph accurately on a symposium, so I'm doing my best. So we're taking our green graph and moving it 3 left and 1 down. So this point right here that I've starred, x, that was an x coordinate of a half. It's moving 3 over and 1 down, so it's landing there. This value here, 3 left, 1 down. It's landing there. This point here, 3 left, 1 down. And so my graph looks something like that. You can check that out on your calculator. From what we've got above, our domain is to the right of the vertical asymptote, so x is greater than negative 3. The range, as it is for all log functions, is all reals, and a vertical asymptote for a log function at x equals negative 3. Now just to finish all of this off and test whether our function is correct, let's just use our calculator. So I'm going to enter my original function, which was y equals negative 3 log base 2 of 2x plus 6 minus 1. I'm going to enter that into my calculator. But I've got to remember that on my calculator, I've only got base 10 logs. I don't have base 2 logs. So what I'm going to have to do for this piece is use my change of base rule, which would be negative 3 times, and I'm going to change this to base 10 since that's what's on my calculator. A change of base rule would make that log base 10 of 2x plus 6 divided by log 2 minus 1. So this expression needs to get put into the calculator. So typing in negative 3 log 2x plus 6, that's a base 10 log, remember, divided by log 2. Subtract my 1. I should get the graph that I had further up here. The graph in black matches the graph on my calculator.